Okay, now we're going to look at a trig functions. So here we have we're supposed to graph sine x, cosine x, and we're limiting it to just from 0 to 2 pi, because that really would go on forever in both directions. Okay, so first, as far as domain goes, you can plug in, this is the domain, because we're making it that way. But in reality, you can plug in positives or negatives, any number in for x, and multiplying it's not going to affect things. So the domain would have been all reals, but we're just restricting ourselves to from 0 to 2 pi to simplify when we get ready to calculate things like critical values. Okay. All right. So that's the domain. All right. With first and second derivatives, we did the first derivative, and it required, that was a little tough because you had to use some identities. Turned out to be 1 minus 2 sine squared x. And then f double prime, let's see, that turned out to be negative 4 sine x cosine x. Okay. Okay. All right. Now, so we need to know where f prime of x equals 0 or is undefined. Okay. But that's not going to have any trouble spots. There's no denominators, no radicals, that type of thing. So we're not going to get anything for that. So we really just need to know where that equals 0. So let's do that first. Let's solve 1 minus 2 sine squared x equals 0. So we're going to subtract 1. Don't lose that negative that's left in front of the 2. Okay, divide by negative 2. So we get sine squared x equaling a half. So when you square root both sides, don't forget you're going to get plus or minus the square root of 1/2, okay, which is plus or minus 1 over the square root of 2. And if we rationalize that, we get plus or minus square root of 2 over 2. Now that should sound somewhat or vaguely familiar, okay? All right, so those are the possible critical values, is when you're going to have, it's not yet the possible critical values, but the possible critical values are going to come when sine x equals plus or minus square root of 2 over 2. So now it helps to draw that picture. Think about the unit circle. So when you're at these 45-degree angles, that's when you get that square root of 2 over 2 happening. Okay, and here it would be positive. Here you'd go to the left, but that would be cosine, and then up, which would be positive. Here you would go to the left and then down. And then over here, it would be to the right and then down. Okay, so we're actually looking for where sine could be positive or negative square root of 2 within one rotation. So from 0 all the way around back to 2 pi, just in one rotation. So it's going to happen at these 45-degree angles. So you got to think about what those are. So that would be pi over 4. This is 2 pi over 4. That would be 3 pi over 4. That's 4 pi over 4. This would be 5 pi over 4. 6 pi over 4, then 7 pi over 4. So x would wind up equaling pi over 4, the 3 pi over 4, 5 pi over 4, and the 7 pi over 4. So those are where we're going to have possible critical values. All right, now, when you think about those, I'm going to stretch them out now onto a number line. So let me get it about right. 0, that would be 2, 1, 2, 3, 4. This would be 5. This would be 3 pi over 2. And this would be 7. And then we'd be over here at 2 pi again. Okay. So these spots right here are where potential maxes and mins are going to happen. Okay. All right. So let's think about what the f prime does when you're at 0. Okay, so remember f prime, let me back it up just a little bit. Okay, f prime is this. So when you plug in 0 for sine, the sine is going to be 0. You square that, you're going to be 0. 2 times 0 is 0, so you'll have a positive 1. So this would be positive. Okay, positive 1. When you're at pi over 2, when you put in a pi over 2, the value of sine would be 1. When you square that, you would get 1. Times 2 would be 2, and you're doing 1 minus 2, so that would be negative. So this is going to be negative. Okay, 3 pi over 4, you'd be at 0. So now when you plug in pi, sine would be 0, so you'd be back to a positive. When you're at 3 pi over 2, sine would be negative 1, and so sine squared would be positive, and then you'd have 1 minus 2, so you'd be negative again. You see that periodic look to this? Okay, and then when you're at 2 pi, that's the same as 0, so that's going to be positive. Okay, and so that means it goes up, not necessarily perfectly constantly straight, and then it goes down, and then it goes up, and then it goes down, and then it goes up, kind of like what you'd be expecting. So it looks like we're going to have, a max here, a min here, a max there, and a min there. And so that's pi over 4 something. Okay. And then 3 pi over 4 something. And then 5 pi over 4. We already know the something because we already had that previously. And then 7 pi over 4 something. And remember that this is what the outputs turn out to be. So at pi over 4, your sine value is positive. 3 pi over 4, your sine value is positive. But at 5 pi over 4, your sine value is negative. And at 7 pi over 4, your sine value is negative. Okay. Oh, wait a minute. I don't want to plug it in. I'm plugging into the, hold on. Ignore me for a moment. Okay. Getting back to this after having a break. Okay. Hold on a second. All right, I got to remember what I'm plugging into and what I'm doing. So I wasn't really thinking through things. All right, so we know whether they're maxes or mins. Okay, this tells us what F is going to look like. I need to go to F, so I have to actually go back and remember what F was. And F was sine X, cosine X, wasn't it? So that's what I need to plug in there. All right, so let's see. So that would be sine pi over 4, cosine pi over 4. So I'm still going to look at this same picture up here, but I forgot at all. I wasn't even thinking about what I was doing. So I'm trying to find the value of F at pi over 4. Sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is square root of 2 over 2. So that is going to be the product of those. So that's going to be the square root of 4, which is 2 over 4, that's going to be 1/2, and it'll be positive. Okay. All right, let's look at 3 pi over 4. So it's still going to involve square root of 2 over 2, but we're going to have a positive and a negative, so it'll be negative. 5 pi over 4, we got them both negative, so that's going to be back to positive. Okay. And then at 7 pi over 4, let's see, that's there. We're going to have one of them negative, so that'll be back to a negative. Okay, that's better. All right. Okay, so those are the extreme values that you're going to have on the interval from 0 to 2 pi. All right, now let me go back up here. So hold your thought on that. And let's go take this one and find out what causes it to equal 0. It can never be undefined. And you got a product, so you can set each of those equal to 0, but of course you don't get anything from that. And then where does sine x equal 0 and where does cosine x equal 0? Okay, so then you got to think about that. It helps to just look over here at the unit circle. Sine x would wind up equaling 0 when you're at x equals 0 or at x equals 2 pi. All right, and then cosine x would equal 0 when you're up here or down here. So that would be true when x equals pi over 2. And also when it's 3 pi over 2, right? Cosine would be 0 there as well. Okay. Now, let me think about that. Sine x would also equal 0 at pi, right? Because you'd be over here, it would equal 0 as well. Okay, so there and there. So 0, 2 pi, and pi. And we're graphing it on the interval from 0 to 2 pi, so we want to include both of those. Okay. All right, so now, and these are all going to be from here. So 0, let me get my pi, my 2 pi. Maybe I could just put it, well, that's okay. All right, and then here we have our pi over 2, and here we have our 3 pi over 2. Okay. All right, so we want to pick, these are the possible spots where you could have an inflection point. All right, so we want to check in between each of those. So I'm going to do the fourths to check in between. Okay, so if I check in between, that would mean I'm going to think about what happens at pi over 4, and then at 3 pi over 4, these are what my test points are going to be. And then at 5 pi over 4, and then 7 pi over 4. And I'm looking at f double prime, which is the -4 sine x cosine x. All right, so at pi over 4, both sine and cosine are positive. Multiplied by -4, you're going to get a negative. At 3 pi over 4, one of them's going to be negative, and then the 4 was negative, so that's going to be positive. At 5 pi over 4, they're both negative, so these are both negative, making them a positive, and then the 4 is negative. And then at 7 pi over 4, one of them's negative, but the 4 is also negative, so you're back to a positive. Okay, and that was f double prime we were looking at. So what that tells us about f is it's going to be concave down, and then up, and then down, and then up. See, these are the intervals. It's concave down, from 0 to pi over 2. It's concave up from pi over 2 to pi, down from pi to 3 pi over 2, and then up from 3 pi over 2 to 2 pi. Okay. All right, so that means it changes. It changes here, and it changes concavity there, and it changes concavity there. Okay, so that means pi over 2 is going to be an inflection point. We'll find out what goes with it. Okay, 5 pi over 4, 3 pi over 4. Wait a minute. Concave up. Okay. All right, pi, sorry, goes from right here, right here, right here. So pi something, and then 3 pi over 2 something. And remember, when we plug into the something, we got to go to f. So that's the one that's sine, cosine. So sine pi over 2, cosine pi over 2. If you multiply those, you're going to get a 0 because cosine's 0. And with pi, sine is 0. So when you multiply sine of pi times cosine of pi, you're going to get a 0. And that 3 pi over 2 is also going to be a 0. Okay. So those are going to be points of inflection there. All right. Okay. All right. So let's go ahead and begin our sketch. All right. So, oh, we were only going from 0 to 2 pi, so I don't have to go to the left side at all. So I can really focus here. I like to just do 0 and 2 pi. Cut it in half would be pi. Cut that in half would be pi over 2. And then cut each of those in half. You're breaking pi into 4 units. So this would be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi. This would be 7 pi over 4. Okay? All right, and then it looks like for our y coordinates, we don't need to get very high. So if that's 1, and this is -1, looks like I just need the halfway. Okay. In fact, let me make this 1/2 and this -1/2 so that I have plenty of space. Okay. Right, so make that 1/2. Make that -1/2, and so 1 would not be until you down here. -1 and 1. Okay. All right. So pi over 2, 0, pi 0, and 3 pi over 2, 0. Those are going to be inflection points. Okay. Then pi over 4, 1/2 is a max. 3 pi over 4, -1/2 is a min. 5 pi over 4, 1/2 is a max. And 7 pi over 4, -1/2 is a min. Okay, and then we didn't do the ends, but we're at 0. If you plug into the f function, you would have a 0 and there at 2 pi as well. Okay. All right. And then you know how trig functions kind of go, so that would enable you to go ahead and sketch that. Okay. So it's going to go have a maximum, relative maximum, then a minimum, then a maximum, then a minimum, and then a maximum. And see what's happening is it's changing from being concave down to concave up. And see, it was supposed to be up between pi over 2 and pi. See how it is? It's supposed to be concave down between 0 and pi over 2. And then and so on. And then if you also check on the f prime, see how it's increasing, then decreasing. Okay, and it's increasing until you get here. It's decreasing to pi over 2. And then this is the one from pi over 2 to 3 pi over 4. It's from pi over 4 all the way to 3 pi over 4. It's decreasing. It continues. It's just the concavity changes. Okay, so here it's decreasing, but at an increasing rate. See how it's the function is going down, but it's less and less negative. So the slopes are actually increasing. Okay. And then here it's increasing all the way like it's supposed to, and it's concave up on this part, concave down there, and so on. Okay. And we're only going to 2 pi, so we can stop at that point. Okay. All right. And we didn't really go in and do x-intercepts and y-intercepts because they kind of come out. These turn out to be the x-intercepts. So you don't have to always do everything that they ask you for to get a good picture. Okay. Okay. All right. So that was a trig function. All right. I'm going to go ahead and do number 7 also. All right. So on problem number 7, we're looking at an ln function. So these are a little less familiar to people. Okay. Actually, let me just stop with the trig so I can post that one real quick since some of you are working on this.